All right, good morning and happy Wednesday. I'm planning on doing LeetCode contest 310 virtually. This was last Saturday's contest, which I missed, unfortunately, but do it virtually is second best, I suppose. So here we go. Open these guys up. Time to shine. All right. The even elements that appear the most. Turn the smallest one. All right, so we can use a map. And for each value x in the input array A, if x and 1, then it's odd. With this is even. Yeah, we'll just increment the count, right? So m sub x plus equals 1. And keep track of a high count. I equals max m sub x and high. All right, and then see return for minimum x for x count in m if count is equal to high. Something like that. Uh-oh. Cannot pack non-iterable object int for m.items. 2, that was good. Oh, excuse me. 2, 4, and -1 in that case. Okay, min doesn't exist. Or -1. All right. Uh-oh. It's empty sequence. Let's do this. If high, else 0. High does not equal -1. -1 is an ascensional value. Else -1. 2, 4, -1. Looks good. Yeah, I mean, that's a decent solution. Nothing too fancy. Let's do this real quick in the other languages. Then we'll post it and move on. Let's use a map as our map. Our counter. All right, then we have high. 1. So for each value x in the input array A, if not x and 1, so basically it's not odd, then we'll increment the count that, and then set high equal to maximum of high, and m sub x. All right, so that's like the highest count. Right, okay, so return actually it's easier maybe to just iterate through the map. Your auto x count in m if count is equal to high. Let's do this actually. We'll have a list of candidates. Maybe we'll change this up here in a little bit. Transform the map. Insert candidates. Destructure the pair, and then take in high by value. Let's do, actually it's not transform, but it's copy if return count is equal to high. So should that be, that's not what I want. Actually, I'm making life hard on myself for no necessary reason. Remember to keep it super simple, don't do anything too fancy, right? So the count's equal to high, and we have a candidate, right? Oops, vector of integers. It's our candidates. Okay. And push that onto that guy. And then return and size, if it exists, we'll return the object and location minimum element of candidates. Otherwise, we return -1. I think that looks good. Okay, so that's cool. On 3, JavaScript, and Kotlin. And then we'll move on to the next question. Let's see, grab this guy, it's cool. Okay, grab this guy. That will be our counter. If not x1, that's even. X is equal to 1 plus x if it exists, or initialize it to 0. And then let's keep track of the high. 1. I equals the maximum itself and count of x. All right, and then we can return m. Let's see, hold on. If I exceeds -1, then we'll return and filter our dot map. Oh yeah, I'm going to filter first. Each value, as long as the count is equal to high, we're cool. And map it to the second or the first value. I don't really care about the count. And take the minimum of that. Okay, otherwise, if high is equal to -1, return -1. Looks good. It's cool. Okay, and then do Kotlin. Oops. Map of integer counts for each value x in a. If x modulus 2 is equal to 1, and m sub x equals 1 plus m sub x if it exists, otherwise 0. Track of high as well. Here. That'll be initialized to -1, and high equals maximum itself and m sub x. All right. So return if I exceeds -1, then the minimum value of that count. And filter and submit equals high. That's the count. Dot min. Okay, that should be okay. I thought, oh, okay, hold on. Needs to be X. Oops, I don't care about X because it's the count. Is equal to high. Oh, I need to change that. So filter it, dot map it. Care about count on X. Oops. There we go. That should be fine. Uh-oh. Expecting filter. Oh, do I not need the, oh, oops, I need a pointy thingy. Whoa, this is way off. Hold on. 1, 9, and 7? What? Oh, it needs to be even. Huh? Okay, that looks good. Oops. Okay, cool. So there's Kotlin, JavaScript, Python 3, and we saved the best for last. That is Rust. All right. So M will be our hash map, which is our counter. Object and location from the entry sub x dot or insert 0 is equals 1 if x modulus 2 is equal to 0. Oop, oh. Okay, so there's our count, and then we also want to have a high. Oops. Hold on. M dot get x dot unwrap or else 0. Something like that. I'm pretty sure I'm gonna have to come back and fix this because there's a good chance there's compile errors. That's how I code in Rust. The compiler tells me what to do. Okay, so if I is equal to -1, let's return -1. Otherwise, we'll return return if I is equal to 1. Let's do this. If I exceeds -1, and we'll return the main chunk we want to. Otherwise, return -1. Okay, so high exists, so we'll find the entry. The count is equal to high. M dot the entries. Hold on. Where's hash map? think it's entries, into keys, values. I want to go through each. I want to iterate through each. Or book into. Oh, this is what I want. Okay, just destructure it straight up. Okay, so for him. Wait, hold on. Oh, I need to do into iter. Okay, m dot into iter dot filter. Count equal to high dot map x. Oh wait, hold on. I don't need to do this because I'm doing into iter, so it removes it. I think. Dot min dot unwrap. Wait, hold on. Dot. I don't know if I can do min or I have to collect it first. I think I do have to collect it, right? Collect ai.min unwrap. It's optional. Okay. Okay, gotta borrow this guy here. Oh, I need a in squiggly thing there for the if condition. Uh-oh. Hold on, something's not right. If that, then uh-oh, that's not right. This thing should not be there. Sort of dereferencing the borrow. Oh yes, that is right. The object and location of that thing. Okay, and then value type by 32 cannot be built from reference to that thing. Hey, can I grab this thing by reference and dereference it? Oops. And compare. Two cannot be dereferenced. Not found in that guy 32. Expected one argument. Oops. Expected integer found reference. Remove the explicit borrow. I might come back to this one because this kind of sucks. Supplied zero arguments. What is this? Plus vector minimum value. Right. How the heck do you get a minimum value in a rest vector? Iter.min, right? I'm collecting .min.unwrap, right? What the heck? Isn't that what I'm doing? Here, let's just do this. Yeah, we'll do it. We'll do it C++ style, the long way. For x count and m into iter. Let root cans equal vector. If count is equal to high, then use show the candidates to push x onto there. And then in the end, we'll return y exceeds -1. Let's return -1, the minimum of the candidates, right? Cans dot into iter dot min dot unwrap, right? Is that how it works? Something like that? Maybe not. It doesn't live long enough. Or later here. Doesn't live long enough. Yeah, I can clone it into this guy then. I thought G cannot be dereferenced. Okay, fine. X does not live long enough. What? Oh, high is mutable. Okay, and then X doesn't live long enough. X is dropped here while still borrowed into iter. Let's do that. And I32 reference. What isn't X living long enough now though? I need to borrow X. Integer reference. Borrow occurs there. Borrowed. Just dereference included. I32 cannot be D. Okay. Going back and forth here. Fixing one thing, breaking something else. We're almost there, I think. Oh, dang, it still doesn't live long enough. Let's just do this. Let's just start cloning stuff. Really? Brown Phi doesn't live long enough. It did not live long enough. Let's clone X here. This is ugly. Just make a brand new Y. For each value X and A. Oh, it doesn't work regardless. Interesting. wonder if I can explicitly mark these things as borrow. Integer cannot be dereferenced. Strange, because I thought that integer was a reference explicitly. So I don't understand you, Rest. Okay, this is like super lame. It took like 30 minutes on the first question. Whatever. Okay, we'll do this later. To do implement me. Okay, whatever. Let's just push this up and move on. All right, a few solutions. All right, use a map M as a counter a frequency of each value X of the input array A. And it's cool. Each even. Okay, nothing too fancy there. All right. Optimum partition of a string. Let's see how much time do I have left. 1 hour, 30 minutes. Oops. So Q1 to about 30 minutes. And because of Rust. All right, 1 hour. Main contest. Okay, here we go. That they're unique. Okay, so we can just do a sliding window. Minimum number of substrings needed. Partition. Okay, so we need to keep track of the last index of each character and then take a slice there. Starting off with 1, 2, 3. Oh, wait, hold on. What is this? Each substring itself is unique. Okay, so we take. I suppose, yeah, we'd always want to just greedily take as much as we can, right? Yeah, so sliding window and take. Oh, CAB. Wait. Take. 1, 2, 3, and then 4. Yeah, let's just try sliding window first. It's the length of S, I0, J0, so I to J non-inclusive. Okay, so while J is less than N, so create a map, your counter, or no, actually just be seen. It's just a set. Set of scene values. Excuse me. Okay, so while a sub j, while j is less than n, and a sub j is not, oops, not in scene. C dot add a sub j and increment j. And then our partition count will start with 1. And then we start with 0, right? Start off with 0. And let's equals 1 for each partition. Okay, so then I equals j. And C equals brand new set. Trying to count to the end. Okay. Something like that. Oops, what happened? Regex flag object is not subscriptable. Oh, A is S sub J, S sub J. A sub J. Okay, so 4 is cool, 6 for the other one. Okay, that's good. All right, that's cool. Okay, so that took like 5 minutes or so, so that's cool. Remember to keep it super simple. So let's write this real quick in the other languages, and I'm pretty sure I can write this one in Rust. I'll give it a shot again. Oh, Rust, you give me a hard time. All right, we'll turn the count to the end here. And then we need a set of scene. Oops, using set is a one-word set of characters seen in the string. Set scene. Okay, and then 10 is s start size, minus 0, and j is 0, while j is less than n. There we go. While j is less than n, and a sub j. C not find a sub j is not equal to c not n, right? So j is not in c. Increment j. And then, oops, hold on. C not insert a sub j plus plus. Okay, then let's count. And then scene equals brand new set. And I equals j. Basically reset stuff and increment the count. Oh, A is S, S sub j. I always think of these things as array of characters, not necessarily a string of characters. Oh, j is less than n, and c dot find S sub j. Let's do this. Actually, easy. And scene dot insert S sub j dot second. Scene clear. Okay, that looks cool. Yay. Okay, let's do this in the other languages and let's move on. It'd be awesome to get to the Q4 with enough time to do these other languages too along the way. Okay, we'll do these real quick. Let's see this guy. Let's do this. I, J, N, so monotonically increasing where they should be. I think this is cool. That's cool. All right. That'll shorten it up a little bit. And then let's just do this for C++ real quick. Auto ij and n equals tuple 0, 0 s dot size. Looks good. It's cool. Okay. Let's move on. Okay. So count to 0, return the count to the end for each character C and the input string S. Scene is a mutable set of characters. If, oops, hold on, what am I doing? Move I and J up as a sliding window. Oh, actually, you know what? I don't need I and J, do I? I could simplify this. I am making it simpler, right? As long as it's not in there. So scene that contains C. Then we'll have to create a new partition. Okay. Scene.clear. Otherwise, let's do this. Scene.add. Yeah, otherwise, we don't want to add it always, right? Scene.add. C. So if it. No, that doesn't right. Yeah, I'm only using J in the other solutions, so I think I can simplify it, right? So scene, if it contains the character C, increment the count. So 1, 2, 3, 4. Okay, so count needs to be initialized to 1. If it contains it, we'll increment the count and clear scene. Otherwise, we'll add scene onto it. Okay, I think that works, right? And we don't even need IJ, right? There's no sliding window to it. No, that's not right. Yeah, I guess you don't need to change the game plan. It did work fine, right? But I'm thinking of it. I didn't use I, did I? I'm not even using I. I'm just using J. All right, this is silly, right? I can so simplify this. All right, without the sliding window. Here, n is equal to length of string. Then, do I really need that? We'll go through each character and then reset, right? Hold on. Or C and S. If C and scene, count plus equals 1. Scene that scene equals brand new set. Is it that simple? No, it's not that simple, right? No, hold on. Right, while it's not in scene, you add it. And then when it is in scene, you increment the count by 1. then clear the set. Insert clear. And then you skip it though. Right, so there does need to be an explicit else. We have to skip it so it's not overlapping. 2 and 3, that doesn't seem right. Okay, I do need to add it though. Okay, yeah, so it should start off at 1, and this is fine. This should work, right? You start off at 1. Okay, yeah, so this is simpler, and this is like exactly what I wanted, right? So start off with the first partition, and if it's in the scene, you clear it and add 1, otherwise, and you always add onto the scene, okay? Okay, this is way better solution than that sliding window. So sliding window ij, oops. Just need to keep track of the scene while we count our partitions. Okay, so let's fix up C++ and we'll post these solutions. And then that's enough. I don't need to perfect this. Each character in string s if not seen dot insert c dot second. Oops. So you go to the count and clear scene. Right, and then scene. Oh, actually, still want to add it to scene though, right? Scene dot find c is not equal to scene dot end, and we'll clear it scene dot insert c. Always insert it regardless, and then we'll start it off at 1. Okay, yeah, that should be fine. Right, nothing too fancy. Just keep it super simple. Cool. All right, let's do JavaScript, Kotlin. Right, so if it contains it, then we'll clear it and then always add it for the current partition. And we'll start off the count at 1. Yeah, so that's cool. All right, go. Yeah, note to self, if you make a sliding window of I and J and you end up using I, then the sliding window there's no reason for it to exist, right? Might as well keep it super simple and don't do anything too fancy. Initialize count to 1 for the first partition. Inclusive, then for each character of the input string s, scene dot has that character, then implement the count and scene dot clear, and then scene dot add character. All right, nothing too fancy. Boom, bam, good to go. Let's move on. All right, hit on the Q3 here. In a second, or let me scene equals hash set selections hash set which character is charged and the count in the end. That's count equals 0. Okay, so if scene that contains that character, add character or insert. Okay, and then this guy would be count is increment of 1 and scene is cleared. C does not live long enough. Oh dang. clone it. Is that cool? Sorry, cannot be dereferenced. Okay, just like that. Okay, cool. And then initialize count to 1. Should be good to go. Okay, cool. All right, so there we go. The brief description up here. Form a linear scan of all characters C of the input string S, tracking what's been seen. I guess which characters have been seen. To return the count of partitions. Sounds good, nothing too fancy. All right, a few solutions. Yes, when a character has been previously seen, we must create, I guess, increment the count of partitions. Right. Perform a linear scan of all characters C of the input string S, checking which character has been seen to return the count of partitions. When a character has been previously seen, we must increment the count of partitions. Right, I mean, it's kind of redundant. Right, by 1. Okay, it doesn't have to be perfect. Good enough, whatever. Okay. And 42 minutes left in the contest. 42 minutes left in the contest. Oops. Left in the contest. And so Q2 took about, was it about 18 minutes or so? Okay, I got a little bit of hung up. And wasted time using the sliding window IJ, where is I didn't even use I. Variable I. Oops. Other than that, I ended up finding that out as I wrote it in Kotlin, so that's pretty cool. All right. Anyhow, let's go. Oops. Okay, so we can sort the input and then do a linear scan. Or hold on. We can do actually union find of non-overlapping intervals. Right, union find of non-overlapping intervals. Union find of non-overlapping intervals. Right, or would there be another way to do this better? The 1 and the 5 can only go with the 6 and the 8, right? I mean, it never makes sense to put one in another group but not in another in any way. No, I don't think so. Let's give it a try. I think so, yeah. Oops. Let's give it a shot. parent of x. So if parent of x does not equal x, then parent of x equals find that parent of the x. F union A and B equals find A, find parent of A, find parent of B. Parent of A equals B, which is an arbitrary choice. Oops. That is, we can make B the parent of A or A the parent of B, it doesn't really matter. Arbitrary choice. Okay. And then return sets length, oops, the length of the set. Find x for x in, hold on, let's do this. N equals length of A, P equals I for I in range in. These are parent representatives. Representatives of in disjoint sets. A little smiley face here because they're happy parents. P. Okay, and then for. Oh, actually, you know what? So this is still going to be a quadratic solution, right? Is it? Yeah. Oh, dang. Okay. I think, hold on. I need to think about this again. Right. Because maybe my original intuition was sorting it by the start. But actually, this is more difficult because we have 100,000 elements, and the obvious solution is just to, for each one, go through each existing bucket and try to add it to an existing bucket if we can. But that would be quadratic runtime, which would TLE. I wonder if we can binary search. How would this work? The quadratic is pretty straightforward, I think, right? Each interval compared to every other interval, or every other bucket, and then stick it in whichever one we can. Well, each of them are an individual bucket of themselves. Uh, it's insane. Each parent representative could have a high and a low. How do I union them without a quadratic comparison of all IJ pairs, though? I mean, all IJ pair comparison is naive and will TLE. Yeah, this one is subtly tricky in that I'm not seeing a way offhand of avoiding the IJ comparisons, which is quadratic, which will certainly TLE. So a million values, and the values from 1 to a million inclusive, and there's 100,000 intervals. Well, yeah, this is not right. Right, union find initially I thought would work, but you still need a quadratic comparison, right, of IJ pairs, even to do the unioning. So the other alternative is to write a brute force solution and then optimize it. Okay, so no, I'm not seeing how we can avoid Tilly here. So brute force is a good start. All right, let's do that. So I have a bucket of highs and lows. But then there's things in between as well. I could do union find and I suppose I could join the ones that don't overlap, but it's not going to save me time because there's like these separate chunks. Man, yeah, how would I even brute force this thing? Like every single value in every single group. Make sure it doesn't conflict with it. Then you can add it to the group. That's assuming that there can be any arbitrary non-overlapping order as long as we greedily fill them. Okay, well, let's do this. Groups. Turn the link to groups for IJ and A. It's our interval. For group and groups. Okay equals false. Okay, we'll track our placement. If okay, then break. That means we found a group and we can put it in. Okay, I don't know if we need that or not. So if not, okay, then groups dot append a new group of IJ. Make an array of arrays for U, V, and group. Okay equals true. If J is less than U or I is less than V. Wait, V is less than I. UV is to left or UV is to the right, right? If UV is to the left, then I is less than V. Oops, or J is less than U, right? If it's not, right? IJ is here, UV is there. IJ is there, UV is there. Okay, equals false. Break. So if it's okay, then this group that append IJ. There we go. Okay, something like that. 3 and 1. Okay, so that's brute force. That should TLE. And it'll take forever. It's expected to TLE. Oh no, it's the wrong answer. Dang. Output's 20. Okay. So it might not be quite that naive then. So it might not be that quite that naive. And anyhow, if this was correct, it still would have pretty sure what a TLE, right? So for each interval and each value that's already been seen in the groups that we created. Okay, let's move on. Dang, yeah, that sucks. Okay, well, whatever. Okay, we got 27 minutes left. 27 minutes left in the contest. Yeah, so again, a quadratic solution is pretty quadratic. Is straightforward, I think. That will TLE. Whatever, it's a good start. Basically, tracking the best ending at each jth index. Best is equal to 0. Try the best in the end, then is length A for I in range, or J will be the outer loop. J in range 1 to n, non-inclusive. For I in range 0 to j, non-inclusive. If a sub I, or a sub j minus a sub I, want to be increasing, so we want a sub I to be less than a sub j, and is strictly increasing? Yes, strictly increasing. And a sub j minus a sub I is less than or equal to our threshold. So we call that t. And have our dp sub dp equals 1 times n. All right, so dp sub j equals the maximum of dp sub j, or 1 plus dp sub I, basically appending j onto the previous best I. Best equals the maximum of itself in dp sub j. Right, something like that is the brute force dp 541 5400. 1, always 1. Okay, so that should TLE for reals this time. Last time I thought I was going to TLE, I got a wrong answer. Okay, so it is a correct solution, I believe. Yeah, it's like this thing, it's like 100,000 values. So yeah, okay, quadratic solution is going to TLE. And I remember that Coach had come up with a near linear solution for this using bisect. But I never really learned how that worked. It's almost magic. I remember what it is. It's longest increasing sum sequence, problem number 30 from LeetCode. Oops, right. Pretty sure this dude wrote something that I built upon. I pretty much like copied what he said. All right, but this is the easy one. Yeah, okay, so this is quadratic. It's like a monotonic Q. So monotonic Q is incorrect since it kicks out. This is 0 here. Any search is correct since it skips past. Yes, I see. I still need to do this in Rust. Okay, so yeah, that TLE'd, and then I want to use this as a reference. Right here, refer to Coach's near linear solution. Oops, this is the wrong problem. This is number 3, which is totally wrong, right? So this is this guy. All right, so bisect it and then set it to that value. Yeah, so I still need to understand how this works a little bit better if I'm going to actually get this accepted in the contest. So S is our stack. It's kind of like a monotonic Q, right? A monotonic Q that overwrites itself. Right, if you can append it onto that. So let's just do this for now. Let's go with a sub 0. Okay, that, right, so 4x. And now what's remaining after we skip that first element? If bottom is less than x and x minus s, the last one on the stack, less than or equal to our threshold, then we can build upon it. And so x can go on to that increasing value. I equals bisect s. Right, so we overwrite that value I wonder if this works. And if it does, I don't really understand why. List assignment. Bisect left. Like this. I don't think this does what I want. Does it really? 541. Oh, hey, maybe it does. Let's see what happens. If it does work, this is like totally cheating because like I don't understand how this works, honestly. Like, how does this work? I need to really look at it. Okay, so it is the wrong answer. I'd feel really bad if I got the right answer. It's like, dude, it's just totally lame, right? It's less than or equal to. Wait, no, it's less than. Yeah, it doesn't work out right. Yeah, to actually understand what I'm doing, I can't just be guessing, throwing things up on the wall. Okay, so anyhow, I think I'm gonna call it a day. I have 17 minutes left, but I'm really dragging on these last two. I'm totally worn out, throwing things up on the wall to see what sticks. All right, I'll catch you next time.